So we have been discussing on the various types of lipoproteins and how are these lipoproteins formed, what are the functions of the lipoproteins. That all have been completed. So lipoproteins are nothing but a complex of lipids with the proteins. So what's the function of this protein part? The protein part enables the lipids to move, run, or move smoothly in the bloodstream, right? So that they can carry out their function. And the protein part of the lipoprotein we call it as apolipoproteins, and apolipoproteins are of different classes, and based on the type of the apoprotein which are present, and based on the size, based on the density, based on the electrophoretic mobility, based on the differences in the electrophoretic mobility, based on the type of the apoproteins which are present on the lipids, they are divided into different types. The lipoproteins are broadly divided into 5 different classes. The chylomicrons, which are the least dense molecules, followed by the very low density lipoproteins, then the IDL, that is the intermediate density lipoprotein, then comes the low density lipoprotein, and the highest density lipoprotein is known as HDL, or it is also known as the good cholesterol, while LDL is known as the bad cholesterol. And the bottom part of the centrifuging tube will be occupied with free fatty acids, or we also call them as non-esterified fatty acids. So this is how they appear when a lipid sample is subjected for centrifugation, ultracentrifugation, based on the differences in the density gradient, or based on the flotation constant, or based on the sedimentation constant. They get partitioned in the form of different layers, and the topmost layer is occupied by chylomicrons. And the function of chylomicron, it is that lipoprotein which is having the largest quantity of lipids accommodated with them, and the type of the lipid present in them is a TG, triacyl glycerol. There is a majority portion area of the chylomicron is occupied with a TG, and the TG is again derived from the exogenous source or the dietary sources. So the dietary TG, the dietary cholesterol, the dietary phospholipids are all transported from the intestine. After the digestion and absorption, all of them will be carried from the intestinal lumen or the enterocytes into the liver by the chylomicrons. The chylomicrons, the main apoprotein present in the chylomicron is the the ApoB48. The principal one is the ApoB48, and it is the only apoprotein which is this is the apoprotein which is synthesized synthesized only by the intestine. All the other apoproteins are synthesized from the liver and also from other extrahepatic tissues also. Again, the ApoA, ApoC, ApoE, different types of apoproteins are there. All of the apoproteins are synthesized by the liver except ApoB48. ApoB48 is synthesized only by the in the intestinal cells or enterocytes. And actually this ApoB48 is derived from the ApoB100. ApoB100 is a protein which is synthesized by the liver, and this ApoB100 and the ApoB48, both apoproteins are products of the same gene. But in the intestinal cells or within the enterocyte, this gene is undergoing a phenomenon known as mRNA splicing, so that this ApoB48 will be having only 48% weight, of total weight of the ApoB100. Because splicing happens, that is, the gene is cut into a shorter piece, so that the remaining protein will be having a size 48% as that of the ApoB100. That's why it is known as ApoB48, and this is the protein which is synthesized only by the intestinal cells. That is, the ApoB48 can be synthesized only by intestinal cells or enterocytes. All the other proteins can be synthesized by the liver. And apart from liver, intestinal cells, brain cells, etc., can synthesize all the other proteins, but ApoB48 can be synthesized only by the enterocytes, right? So from the diet we get different types of fats in the form of TG, cholesterol, fat soluble vitamins, phospholipids, etc. Now what is happening to these different lipids? TG will be acted upon by lipases, right, at various layers or various areas or various portions of the intestinal cells or intestine or the digestive tract to give rise to fatty acids and glycerol. And on entering back into the intestinal cells or intestinal luminal cells or enterocytes, what happens there? The TG is resynthesized, right? Intestinal mucosal cells again, or intestinal luminal cells or enterocytes resynthesizes the TG from MAG, monoacyl glycerol. right? So the TG will be resynthesized within the enterocytes and will be packed into the chylomicrons, right? So this is known as the nascent chylomicron. That is, nascent chylomicron will be occupied with mainly TG, followed by cholesterol. Cholesterol is not the free cholesterol; it is in the form of cholesterol esters. That is, the OH, the third position of the cholesterol is made up of an OH. It is having an OH group, a substitution group, or side chain is there, OH. So the OH H is replaced by a fatty acid, right? So this cholesterol esters, free cholesterol will be converted into cholesterol esters, and the cholesterol esters is also packed into the chylomicron, and it can become a lipoprotein only when the protein part comes and attaches, and the protein part mainly coming as the ApoB48, ApoA1, right? So and again phospholipid, which is a amphipathic molecule. So all these forms the nascent chylomicron. Also the fat soluble vitamins also will be packed into the, you know, what are the fat soluble vitamins? Which are the fat soluble vitamins? Vitamin A, D, E and K. So all these lipid soluble components will be packed, derived from the dietary sources, will be packed into the chylomicrons, and such a chylomicron we call it as a nascent chylomicron. Now what happens to nascent chylomicron? This nascent chylomicron enters into the lymphatic system or the lacteals, reaches the thoracic duct, and from the thoracic duct it enters into the bloodstream, and it will be distributed. The TG will be that is on the during the course of its journey. It will be the chylomicrons with the help of receptors. It gets attached onto the adipose tissues or skeletal muscles or the surrounding tissues. It will be liberating, or it will be releasing the contents. The nascent chylomicrons will be releasing its contents into the surrounding tissues with the help of lipoprotein lipase or hormone sensitive lipases. It will be releasing so that the size of the chylomicron will be reduced, right? So the nascent chylomicron enters into thoracic duct. From there it enters into systemic circulation, and in the systemic circulation, when it enters into the blood, it come across the HDL molecules. HDL means high density lipoproteins. So when they meet the HDL, what does HDL do? HDL releases its ApoE and ApoC towards the nascent chylomicrons or the chylomicrons in the circulation, so that the nascent chylomicron is converted into chylomicron, so that it acquire more and more type of apoproteins like ApoE, ApoC, etc. Right? So the nascent chylomicron will be having only ApoB48, and the other apoproteins are derived from the HDL molecule, ApoB48 and ApoA1. Right? Apart from that, all the other apoproteins, that is ApoE and ApoC, are derived from the HDL when comes into contact with the HDL molecules in the systemic circulation. And such a chylomicron we call it as the chylomicron or mature chylomicron. Right? And this chylomicron will be releasing its contents to the surrounding tissues with the help of lipoprotein lipase, so that the contents, that is the TG, the cholesterol esters will be liberated or it will be released into the tissues which are in demand of these lipids. Arkano avashyalation supply chain supplies all its contents, so that the size will be reduced. So such a reduced size chylomicron we call it as mature chylomicron releases its contents with the help of lipoprotein lipase, so that the surface area will be reduced. Belly size as a big molecule and then becomes smaller and smaller, right, with the help of lipoprotein lipases. And such a chylomicron which with a reduced size we call it as a chylomicron remnant. So it contains the dietary cholesterol and the small quantities of TG, right, etc., and the apoproteins, right? So that's how the chylomicron carries out its functions. And once the chylomicron is formed, once it liberates its contents, what happens? It will be moving towards the liver, back to liver, right? So that's the fate of chylomicron. So we know that the half-life of chylomicron is only 1 hour. So within 1 hour it will be liberated. It will be subjected for catabolism or breakdown. Now that is the case with the chylomicron, the first lipoprotein. Now below the chylomicron, or when you are observing a centrifuging tube, the topmost layer is occupied by the chylomicrons. So next to the chylomicron is the VLDL, that is very low density lipoprotein. So VLDL is a lipoprotein whose function is to carry the endogenous TG, that is the TG which is synthesized by the body, not from the dietary sources. The TG derived from the endogenous sources are transported by another entirely different lipoprotein, which is a VLDL, very low density lipoprotein. So again, the major constant of VLDL is again the TG. But when compared to that of the kilomicron concentration, the TG present in the kilomicrons, the TG concentration or the quantity of TG carried by the VLDL is a little bit less when compared to that of kilomicron. That's why it is having a greater density than that of the kilomicron, right? So it is the VLDL. It's again synthesized by the liver. Kilomicrons are synthesized by the intestinal cells or the enterocytes, while VLDL is synthesized in the liver. That is when, which is a case, or when does the VLDL will be synthesized? The VLDLs are synthesized when the TG production is increased. After TG production increase here, when we are in a well-fed condition, the excess source of biomolecules will be converted into the form of fat. So fat side converted. Fat form, once fatty acid synthesis of the enzyme, what happens? The fat will be stored in the form of TG. So that is how the TG, endogenous TG, is formed in the body. So that is the stimulus for the VLDL synthesis, right? And the main apoprotein present in the VLDL is ApoB100, and we know that ApoB100 is synthesized in the liver, right? So ApoB100, one of the main apoprotein present in the VLDL is the ApoB100. Now, small amounts of ApoE and ApoC. ApoE and ApoC are always derived from the high density lipoprotein or HDL. So it will be incorporated. Once the VLDL is immediately synthesized by the liver, it will be called as the nascent VLDL. Right? ആദ്യമായിട്ട് എന്താ പറയുക, നമ്മൾ എപ്പോഴും എന്താ പറയുക, nascent എന്ന് വിളിക്കുക. അപ്പൊ nascent എപ്പോഴും സൈസ് കുറവായിരിക്കും. Right? So immediately after the synthesis, the VLDL will be having mainly TG and ApoB100, and such a VLDL we call it as a nascent VLDL. And again, when it is released from the liver, what happens? VLDL come across again the HDL in the circulation, and this HDL liberates the ApoE and ApoC towards the VLDL, so that the nascent VLDL will be converted into mature VLDL, right? This is a free fatty acids accumulation will be there. Free fatty acids will be entering into TG synthesis, right? TG metabolism we are already completed. So TG will be formed. Now this TG will be packed within ApoB100, right, to form nascent VLDL, and this nascent VLDL will be attaching more and more ApoE and ApoC derived from the HDL molecule in the blood. See, it is a blood. So nascent VLDL is converted into VLDL in the circulation, right? It is in the plasma that the nascent VLDL is converted into mature VLDL, so that it is acquired or it is having more and more quantities of ApoE and ApoC, which packs the TGs and also the cholesterol esters along with free cholesterol and phospholipids on the surface, because free cholesterol and phospholipids are amphipathic molecules. That is, it will be having a polar head and a non-polar tail, right? And the TG, how is it metabolized? So the VLDL hydrolyzed by lipoprotein lipase, and it will be releasing its contents to the adipose tissue, the skeletal muscles, the surrounding tissues, etc. So that the molecular weight is getting decreased because TG is getting released. So what happens? The VLDL will be converted into TG പോകുന്നതോറും എന്ത് ചെയ്യും? Density കൂടി വരും. Fat കൂടുന്നതോറും density കുറയും. Right? So when the fat content is reduced, what happens? Naturally, the density increases. So VLDL, when more and more TG is released out of the VLDL towards the surrounding tissues, what happens? The density slowly start increasing. As a result of which, VLDL will be converted into intermediate density lipoproteins. So that's how the IDL is formed in the body. Now, this IDL will be again liberating more and more quantities of TG, so that IDL is converted into LDL. So this conversion of VLDL to IDL and finally towards the low density lipoproteins, LDL, it is known as the lipoprotein cascade pathway, right? So again, when VLDL is, once VLDL is converted into LDL, the function of LDL is entirely different, right? Once VLDL is converted into LDL, the LTG concentration will be least in the LDL molecule, because the TG will be, most of the TG will be liberated into the surrounding tissues, so that now the LDL is having more amount of cholesterol esters rather than that of the TG. So LDL is that lipoprotein which is responsible for transporting the cholesterol esters from the liver to the peripheral tissues. So that's a function of LDL. Low density lipoproteins are responsible for transporting cholesterol esters from the liver to the peripheral tissues. So that because it is depositing more and more amounts of cholesterol in the peripheral tissues, making the person obese. It is known as bad cholesterol.